My name is Carlos, and in today's video, we bring to you an interview with an international student whom I've never met in person, but we were able to connect through SciTeens. His name is Oem Trivedi. He is currently an undergraduate sophomore studying physics in India. He's participated in science fairs across Europe, has met some of the greatest physicists in the world and in cosmology, and today he brings insight to those of you who are international students and are looking for opportunities that are outside of the United States. And for those of you in the United States who are high school students that potentially want to study abroad or travel or go see different things around the world related to STEM, he also brings great insight on how you can get involved in an international presence for science. Please check out the description as I include timestamps for different things that we talk about and also some of the resources that helped him get involved in science. Thank you, and please make sure to subscribe, share with other high school students who can benefit from the information that we're spreading, and last but not least, make sure to check out our website, www.sciteens.org.
For having me here. It's a great honor and a pleasure. Yeah, so my name is Om. I'm from India. I'm currently 19 years old, so so I lived all my life in India. A research visit in the UK, and yeah, I'm basically interested in physics and I'm currently doing courses from Ahmedabad University in India. Yeah, and if things were a little bit different, I would probably be at Stony Brook at this time, but that is a different story altogether. So I like football. I used to play drums in high school, I'm quite a metal head as well. My favorite band is Iron Maiden, and my favorite club is Chelsea. And Yeah, most of all is that. Um, the biggest things that I want to do in my life are basically in physics, but like more and so in football. And one thing that I would possibly want to do in my life is to watch a Champions League final or a World Cup final. So yeah, that is about me. So I think the answer to that is twofold. Actually, the thing that got me into science in the first place when I was very young was what I remember. It was in the sixth grade. So basically, in my early school days, I was not a science guy at all. In fact, I hated mathematics and science as a whole, and I attribute that to my own negligence and a bit to the way science was tutored to me in those days. But that all changed in sixth grade. So basically, my mother was a professor at a college. So basically, of a very particular documentary, and it was on E equals to MC square. So I didn't know anything about what that was, but I was just kind of interested in it. So I went to that. I saw it. So basically, that documentary was so good that they basically engineered each part of the equation. E, M, C, and all that. So basically, for energy, they talked about Michael Faraday and all his stuff, all his struggles. For the mass thing, they talked about Antoine Lavoisier and how he discovered the law of conservation of mass. And for the speed of light thing, they got to James Clerk Maxwell. And then finally, they talked about how Einstein struggled as a patent clerk, how, probably the greatest genius uh, alongside Sir Isaac Newton that science has ever seen was rejected to be given a PhD. And, how in all those struggles, he finally came up with four revolutionary papers in 1905, his Annus Mirabilis, and that got me hooked. I just understood that this is the thing that I want to do. This is the kind of life I want to pursue, and if possible, I would want to contribute in any way possible to this thing called physics. And then after that, they were obviously, my parents wanted to me basically wanted me to go into engineering in my early days, and that is kind of like the de facto approach in India. But then once I told them about that I want to go and be a scientist, they were very pleased with that too. And that was not the only documentary that I saw. After that, Brian Greene's documentaries on the fabric of cosmos, Carl Sagan's, obviously I'm also a Sagan guy. Carl Sagan's Cosmos, both the book and the documentary series was very important for me. And alongside that, there were things from Brian Cox. So basically, I've seen all the documentaries that we talk about usually. And I'm a big fan of all the YouTube channels on physics. Be it yeah, possibly Minute Physics, 60 Symbols, Veritasium, Vsauce. I saw all that, and that was the thing that when I was young. Yeah, I think that is a very interesting question. And I would attribute my experience at the LRSF, uh, you know uh, in the sense that I could answer that to my best abilities. So basically, the London International Youth Science Forum is held every year at Imperial College London, and you get to present your research in front of Nobel laureates, and you get to visit Oxford, UCL, ICL, obviously, and all those great places across the UK. And you get to meet people from across the world. So at the LISF, I got to meet people from around 75 countries. And I formed great connections with people across the world. So from that I got to know that actually science is more of days, and that should be the way. Because because the more we can do in a collaborative sense these days is much more than someone can do on his own individually, or on their own individually. uh, so basically I think that one of the problems that international students, be it in Europe, or South America, Asia, or the Africa, face is so so I think in the US, people are more open, and from people I mean professors. So basically, professors are more open to taking high school students under their wings of any kind of a summer research project. But that kind of exposure is basically non-existent in India, at least. And I can speak for the whole of South Asia. I think Japan has a better exposure at that level as well. But like on a general perspective, besides the US and I guess probably England, most of the other countries don't have that kind of thing. But actually opportunities are everywhere. You see, you've got loads of opportunities in of doing programs in the US, like the Yale's Global Young Scholars Program, or Stanford's summer school, or like I mentioned, the London International Youth Science Forum, or the NYSF in Australia. And in Italy you've got the Lapadera Scientia, which is a wonderful place to like meet researchers and like-minded students from across the nation. Then you've got organizations like the Milset uh, and Rede POC in Russia and across South America, respectively. And if you reach out to these kind of places, eventually you will get some good experience in research. And I think that more often than not, I know that professors won't respond to any kind of email or messages, especially from high school students. But if you write a particularly genuinely interested email, like obviously if you cannot understand most of their research, if you can show that you are genuinely interested in working with some professor, then it is kind of a real possibility that they might take you under their wings for uh, like a summer program. A friend of mine from Taiwan, like worked on a research paper, and like when she was in her in her junior year in high school, and she became a co-author on that paper, and it was like basically published in a very good journal. So obviously, she didn't have all the knowledge in the field, but but she displayed genuine interest in working with the professor in Taiwan, and she got to understand MATLAB and all these great resources, and she did some cool simulations, simulations of astrophysical jets. So the best tip that I can provide is continue to reach out to any kind of scientific organizations or professors, and eventually you will get your answer. That is a question very close to my heart, and that is a question not many people ask me, but yeah. So basically, my field of research at this point of time is in cosmology, mainly in cosmology, but actually it is at the interface of cosmology and what we call modified gravity theories. So basically, cosmology, as many of you might know, is basically the study of the universe, and from the more theoretical uh, perspective, and basically how the universe evolved into being what it is today, and all the cool stuff, like the Big Bang, cosmic inflation, Big Bang, nucleosynthesis, and cosmic dust, and all that stuff. String theory is, I think this is the most hyped up theory in physics that there is today, and for a good reason. Um, so string theory is one of the prime candidates for a theory of everything, and that statement I think is very strong, and will take anyone's attention towards that idea in particular. And modified gravity theories are are the only thing which I think I need to expand upon a bit. So basically, Einstein's theory of general relativity is a very wonderful theory, and it has been with us for over a century now. And its predictions, whether it is the black hole or gravitational waves or stuff like that, all its theoretical predictions have been mostly verified as well. Even stuff like gravitational waves, which were experimentally verified after 100 years, after which Einstein showed them theoretically. But the thing is, Einstein's theory of GR, kind of fails at two very important stages in the universe. One is that, Einstein's theory cannot explain the very early universe, like, what we call uh, the Trans-Planckian time. Uh, uh, and uh, and basically, at the center of black holes, there is a very famous problem of the singularity, on which Stephen Hawking worked very hard across his life, and the newly crowned Nobel laureate Sir Roger Penrose also worked on it. So basically, in order to see those problems well enough, we think that we need a theory of quantum gravity, which can be string theory. But many people want to attempt to change Einstein's theory of general relativity on the surface level itself. So basically, we call it the low energy limit. So basically, we are talking about the very large scales and the classical scales of Newton, but we are not talking about the quantum scales. So basically, we want to change Einstein's theory of general relativity on the scale of things at which it works out. So what we do is that we add in different geometrical perspectives, like uh, 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 and that has given us loads of theories, and not going into into much, but basically, in a lot of cases, we have got some very good results. But obviously, many a times these theories are not very well motivated. Like Einstein's theory was uh, was motivated from the very famous principle of equivalence. But these theories, more or less, are mathematically motivated. But uh, it is very nice to see how we can just change the most dramatic theory of the 20th century by a few equations itself. So basically, that is what excites me about working on this. So basically, I'm working on the interface of these three things, and I'm trying to work out what what, they imply on dark energy and dark matter. And more specifically, at this point of time, it is on dark energy. So in conclusion, I would say the thing which motivates me the most and inspires me to work on these theories is basically like this thing is so damn cool that in my opinion, it warrants to work uh, on any on any day of my life. And I cannot imagine spending my life in any uh, in like in so basically, that's the reason why. That is a very important issue, because we face this issue at every level. It's not that it's not that uh, like the high school researchers face it only, but people who are undergrads, or or like who are PhD students, who are postdocs, and even professors face this thing. And most of the ideas that one comes about at the surface level, never work out. And this is something which is completely novel in science. So yeah, so in my experience, so basically, the first paper that I wrote was on quantum field theory, and it was on the very famous Feynman propagators. So basically, I was working on Feynman's approach to quantum field theory, and basically, uh, the great thing is that that was not the project I set out to work on. So basically, I wanted to work on something known as the anharmonic quantum oscillator, which is like which basically we talk about simple pendulums, right? Things oscillating like this and that. So basically, that is a simple harmonic oscillator. So a characteristic of the ideal simple harmonic oscillator is that we only consider very small angles at which the oscillator oscillates. but but if you want to oscillate it at very large angles, some um, yeah, some correction terms, and that gives us the anharmonic oscillator. So basically, there is a very famous saying that the life of a theoretical physicist is basically solving uh, more and more complex harmonic oscillators, because quantum field theory, in a sense, basically says that every point in space time is a harmonic oscillator of of quantum energy modes. So basically, harmonic oscillators will never leave you alone. Uh, so please, study that. Uh, but so basically, I wanted to work on that, and I wanted to possibly solve the Schrodinger equation in much more detail with that. And obviously, there are different methods to like approximate it, but I wanted to get an exact solution to this, and I didn't understand how stupid I was at that point of time, because that problem has been shown to be unsolvable. But still, you need those kind of experiences to understand that sometimes things will never work out, and sometimes will never take shape, and that is because uh, uh, so in order to work on the quantum oscillator, I read about 20 papers and stuff like that, went across the whole internet, searched in detail mathematical papers on differential equations and stuff like that, but it all did not work. But all of a sudden, I stumbled about this paper on the so-called Schwinger's method. Uh, so basically, there are two approaches to quantum field theory. One is Feynman's approach, and one is Schwinger's approach. So basically, I started to study about it in more detail, and guess what? In around I would say 2 weeks. Um, so I was working on possibly doing something on the anharmonic oscillator for a month. But after reading Schwinger's paper, something happens, some kind of miracle happened, and uh, and tada! In 2 weeks, I basically combined and calculated Feynman's propagators using using the approach of Schwinger. So and I think that that if that roadblock never occurred, of that anharmonic oscillator bit, then basically I would never be at the position that I am today, because uh, I was kind of depressed for a week after understanding that how would I ever be able to understand a quantum harmonic oscillators in the most exact way. But you know uh, after after the paper was done, and I got some very um, so how do I put it, some very wonderful reviews on the paper. I was very happy actually. Two of the professors who endorsed my work on archive were the ones who wrote me kind of uh, um, yeah. So they wrote me recommendation letters for my university applications in uh, the US. So basically, that was a great thing. So in 2020, I started to work on cosmic inflation and string everything on the interface of that. But what happened once again was, a big roadblock. So I wanted to work on a very specific model of cosmic inflation, and I thought, I would be able to do that in possibly a couple of months. I worked hard on that, and again, it didn't amount to anything, and again, very, you know, uh, shattered by that news. But what happened again was that in that process of for some particular idea, I landed on something known as the Hamilton Jacobi approach to cosmic inflation. And again, not getting into the details a lot, it basically on a completely new approach to warm inflation. So basically, warm approach towards the idea of and basically my approach to warm inflation is is possibly the most general approach to warm inflation which I know at this point of time. So things happen in a very good way, and your learning will never go to waste. Uh, and and the work that I did on warm inflation actually allowed me uh, to like present a paper in the cosmology from home conference, and that was on string theory. And you know in and after that it allowed me in a conference in Korea, and I think it was a big reason for an internship under the legendary cosmologist Dr. Gwindelman at the Ben Gurion in Israel, and basically on the basis of that work, what I'm currently doing on dark energy has got me accepted into the Gordon uh, Research Conference on string theory. So basically, a lot if your ideas, if your initial ideas do not work the way you want them to work, because these uh, these are the things which take you farthest in science, in my opinion. And just keep working, keep hustling, and you will end up with a very good idea, or a very good paper at the very last eventually. like besides my work in cosmology, I'm also working on science outreach. So basically, I always want to give back to the community, which has brought me here as a scientist in the first place. And like as I mentioned before, YouTube videos and documentaries are what have got me into science. um, like currently. So basically, I always wanted to do something which would get high school students into science, and after the London International Youth Science Forum, uh, like a very particular uh, a group of students at the forum became like a really close friends to me, and we all share the same passion towards science and outreach as a whole. Uh, and, uh, and so when the pandemic hit, we all thought that we all have had some wonderful experience in science fairs throughout our high school times, and basically it was through one of these kinds of fairs that we got to know each other. So we wanted to build a kind of a forum which would allow other high school students to form the kind of connections and possibly meet the kind of researchers that we met uh, in the forum itself, and so come aboard the CRW fair. So basically, the CYW is the first of its kind, completely online high school science fair, which focuses on getting the students, particularly from the represented uh, minorities and underprivileged countries, into science, and possibly giving them a platform to share their views on science. And not are necessarily only on research. Like if they have a project already, then uh, uh, then basically this is a forum for you to give your project an international exposure. But but uh, uh, but let's say you don't have a project at this point of time, then our fair basically wants to give you the opportunity to put out your best ideas on which you want to work on. And it might be you might say that your idea is silly, or it might not work at all. But as we discussed, silly ideas eventually will work out. uh, so basically, we want to give students a platform on which they can communicate with each other and possibly form lifelong connections, and also form connections with great people in the world. And we are very honored to have from all the big places in the world who are like completely giants in their fields, who have agreed to become speakers here, and who have also shared life experiences in interviews with us. So basically, this is a platform for you to like present your work, and not worry about the travel costs, because this is always going to be online. And we want that uh, that this fear, let's say, I'm being a bit over here, but let's say in a decade or so, this you know uh, starts to churn out collaborative research papers between students from across the world. Because we have seen that undergraduate students, graduate students, postdocs, and obviously professors uh, write uh, uh, write some wonderful research together with colleagues from across the world. But it has been a rare sight, if was any, that two or three high school students, or group of high school students from across the world collaborated on some research project. So we want to make collaborations between high school possible, and we want to give them the best possible platform to understand how they can be better researchers in the future. And we are very glad to have the GYA and our and our very own scientists for supporting this novice initiative of ours. And that's that. To get involved in research, I'd say the first step uh, is get a topic or a field which interests you a lot, and read all you can about it, whether it is from Quora answers or academia stack exchange, or through books, or through videos, through lectures. Firstly, absorb all you can about the field, and if you have any good idea which you think you should work upon, try to work upon it firstly on yourself, and then start to reach out to any professors or organizations that would support and eventually I think like if it is hustling on, then everything will work out well, and possibly you can end up with a research paper before you even start undergraduate degree. So that's that.